All right, I will go ahead and get started. Good morning, everyone. My name is Snigdha Sarkar, and I am the CFD application engineer here at KETIV Technologies. Thank you so much for joining us for this Ansys Virtual Academy session. We haven't had one for CFD in quite some time, so I'm really excited to be back. Today, we are going to be talking about high-quality data visualization using Ansys EnSight for CFD. And I would also like to welcome my colleague Rituja Kulkarni, who is a new addition to our CFD team. She had some great inputs for me while I was preparing this presentation. I'm not sure if she is here yet, but if she is, shout out to Rituja. All right, so without further ado, let's jump right in. Ansys EnSight. We haven't had a CFD AVA that focuses on post-processing yet. And post-processing is one of the most important aspects of doing CFD simulations, right? Especially if you're handling huge amounts of data, if your simulation setup is really large, if you have a lot of parts and components in your simulation setup, and you wanted to compare and contrast results or cherry pick the ones that make for more meaningful conclusions, then it becomes a slight bit of a problem if you don't have a post-processing tool that can handle all that. So that is why Ansys EnSight is a great specialized post-processing tool. It can not only handle CFD results, but it can handle results from other solvers as well. If you wanted to go ahead and do a coupled analysis when you're tying fluid simulation with structure simulation, and you wanted to analyze the results for that FSI, then Ansys EnSight would be a great data visualization tool. It's quite user-friendly, very interactive. The first time I started using EnSight was during my time at Caterpillar, and within a few days of starting to use it, I was able to pick it up quite easily. So it's very intuitive. And then the good thing about Ansys EnSight is, of course, you can do the basic post-processing that you can also do in other Ansys tools. But if you were to use your post-processing results for, say, marketing or for, say, publications, then you can get some really high quality, realistic rendering, different sorts of animations, volume rendering for particles, for species, combustion related problems. And I'm just speaking from a CFD point of view. I'm sure even from a structures point of view, explicit dynamics, and all the physics heavy stuff can be easily post-processed in EnSight. Another very useful feature that I frequently use is multi-case comparison, wherein you load one CFD case and then another CFD case, and then you compare the results. These cases might be slightly different. Say, for example, you've assigned a different boundary condition or maybe a different operating condition, and you just want to find the difference between the results from one case and another. Then EnSight is a great tool for doing that sort of a thing. I already talked a little bit about animations. When we go into the demo part, you will see that a little bit more in action. And if all this was not enough for you and you wanted to customize EnSight even further, then you always have the option of using Python scripting to make it even more flexible and powerful in terms of post-processing data. So with the help of today's AVA, I just want to introduce the tool to anybody who hasn't used it in the past. I'll be talking about some quick tips and tricks as well. And hopefully that interests you, that piques your interest. And if you want to know more about the advanced functionalities of EnSight, then do feel free to reach out to us, at the end of the AVA. Another thing that I missed to mention at the beginning is if you have any questions, please feel free to add them to the Q&A box that you see on your screen. I will be able to take them towards the end of the session. If I'm not able to answer anything in today's session, then I'll be sure to get back to you. All right, so with that, let's jump right into the usage of EnSight. So I'll go ahead and share that screen. Okay. So hopefully you guys are able to look at my workbench screen. If not, again, just leave that in the chat window. I'm not exactly sure if anybody from KETIV has joined me today. So yeah, help me out here. So we're going to be looking at a couple of examples. I chose 2 different examples to post-process in EnSight. The first case is quite simple. It's a multi-phase simulation wherein we will be looking at volume fractions of a particular phase. And the other case that we're going to do is a conjugate heat transfer problem. Now, I have deliberately chosen a transient case to start off so that I can show you how you would go about exporting the data from Fluent to read into EnSight. Like I said earlier, EnSight is not just compatible with Fluent, it can be used with a multitude of tools inside Ansys. It is compatible with over 30 different data formats, so that makes it really multi-purpose. So even before we go to EnSight, let's go ahead and see what do we have to do on the Fluent side of things to get started with EnSight. So I'll just go ahead and start my multi-phase Fluent case over here. All right, so we have a 2D tank filling case wherein water basically enters from this inlet and then siphons off to this secondary region, which is open to atmospheric conditions. It is also open to the atmosphere at the top over here. I think I have shared the CFD example in the past as well. Nothing too fancy, it's a standard VOF simulation. The idea is to set up a transient case and export the solution at different time steps so that we can later on post-process this in Ansys EnSight. So you go about setting up the simulation the way you would for any CFD case. This is a transient case, gravity is on, multi-phase is on, and then you have some inlets and outlets under boundary conditions. So nothing to be done on this front. The only thing that you have to keep in mind when we post-process this in EnSight is to make sure that we select the frequency at which the data is exported to EnSight, this being a transient case. So what you would do is you would go to calculation activities over here, and I already have an automatic export set up for this particular example. But usually when we're doing a transient simulation, a lot of us might already autosave our simulations after, say, 10 time steps, 20 time steps. So you have to do something similar for EnSight as well. You would simply click on Create, Solution Data Export, and then assign a name of your liking. And then under file type, you can go ahead and choose the data format that you want to export to EnSight. You can choose CDAT if that is more to your preference, because I know a lot of people use CDAT for CFD post. But if you didn't want to choose CDAT, you could also go ahead and choose EnSight Case Code. The difference between these 2 data formats is that there are some functionalities that are present with EnSight Case Code format that might not be present for CDAT, but for most intents and purposes, CDAT works just fine. In fact, for this example, I did export the CDAT case, and then the second example that we are going to do will choose an EnSight case. All right. So you will simply go ahead and choose CDAT for CFD post and EnSight. And then all cell zones are automatically selected by default. The interior surfaces are not. So for example, if you had an interior zone which shows up in your Fluent boundary conditions, that may not be selected by default. If you wanted to go ahead and choose it, you could. And then over here on the right, you have all the quantities that you would be exporting. Now, keep in mind, EnSight data files can get really big, just like Fluent data files. So if you're only going to be working with a few variables, then it might be more prudent to select just those variables from this quantity list. So for example, if I'm only going to be working with pressure, I could just choose the static pressure and the dynamic pressure. But usually for my CFD post-processing, I'll definitely export pressure, density, velocity, temperature, and in this case, even volume fraction, which is right here at the bottom. And then the other part is to ensure the frequency at which this data is being exported. So if you think that perhaps after every 20 time step, if you export the data, you would be able to visualize your results well, then you can enter that number over here. It's going to choose a file name, and then it's going to append the file name with the time step size, similar to what you would do with CFD post, right? It's a CDAT data. So nothing extraordinary over here. I'm not going to click OK because I already have a case over here. So what I did for this particular case was I gave it a new name, selected a couple of quantities over here, as you can see. And then I chose to export it after every 50 time steps. And then I just let it run as usual. So while it was running, after every 50th time step, it was writing out the data that is necessary for importing into EnSight. Okay, so that is all I did on the Fluent side. So I'm going to go ahead and close this up. And we will go ahead and start EnSight. So let me actually go ahead and launch a new EnSight. Okay. I'll just double click on this guy. Okay. So I've opened a brand new EnSight. Nothing has been loaded into it. It says at the top, no data currently loaded. By the way, I'm using the version 2021 R2, in case anybody was wondering. This is the latest version. And now if I want to load my data files into EnSight, I'm going to go ahead and select File, Open. And I am going to go to the correct folder. And the reason why I'm opening EnSight within Workbench is because it's easier to locate that folder wherein you have your Fluent workflow, but you could also launch EnSight from a standalone start menu in a standalone session, right? And you'll see that there are a lot of files in this directory, right? I don't want to bother with so many files. So let me go ahead and set a filter. You will see some options here at the bottom. There's a simple interface, advanced interface, multiple file interface. I'm going to go ahead and choose the advanced interface. And then I'm going to choose a format for this import, which in this case will be Fluent, right? So when you choose Fluent, there will be some comments automatically populated in this field here. It basically tells you how to read in transient data. So this is actually very good information. So even if you forget this AVA, read this part and you should be good to go. So you'll see two fields here. One is the .case file, and then the second part is .cdat file or DAT file. Now, keep in mind, you can read in a Fluent case and data file as it is into EnSight, right? So you don't even need to rely on CDAT or EnSight case code. The reason why I prefer CDAT or EnSight case code is with direct Fluent case and data files, sometimes it's a little bit more time consuming to do the analysis in EnSight because of the data format. EnSight case code is the most attuned to EnSight operations, so it works better. So I'm going to go ahead and choose this first time step over here, which has been appended with 50. This is not exactly the first time step. This is the first export after the 50th time step. So if I go ahead and choose that, you will notice that the CDAT field automatically populates, right? Now, if I go ahead and click on load all parts, it'll only load the data file for this 58 time step. And if that is what you want to do, say, for example, look at any one particular time step case and data file, then great, awesome. You can go ahead and do that. But if you wanted to look at the data file and the progression of results over time, meaning you would have to look at the 58 time step, then the 100 time step, then the 150 time step, then you would have to choose all the data files to be imported into EnSight, right? So what we do is we simply remove the appended time step and instead place an asterisk, which basically works like, your standard, I think DOS operations or what, but basically it skims through your directory and picks up all the data files that have a similar prefix, but just different time steps. So I'm going to go ahead and hit load all parts. And you will notice that the file that I had in Fluent now gets imported into EnSight. So a few things about the interface right off the bat. Because this is a transient case, and because we loaded all those data parts, you'll automatically see a widget here at the top, which is the solution time widget. And I'll talk about this a little bit more in detail when we talk about animations. The second thing that you will see is a parts list. So whatever boundaries, zones you had in your Fluent setup, those show up over here. And those show up under case 1. Remember, I told you guys that you could do case comparisons in EnSight. So if you, for example, had another case loaded into EnSight that you wanted to compare to the first one, then that would come under case 2. Okay, so this is just case 1, and it has all the boundaries and zones imported from Fluent. It also has the fluid zone, right? So this was the interior fluid zone, so that is included as well. If this were a 3D model and it had solid zones, fluid zones, that would be available here as well. Now, the other thing underneath this parts list is, these tabs over here that are variables, annotations, plots, queries, viewports, etc. We'll not talk about everything in detail because EnSight is such a comprehensive tool that, we would be here for a very long time. But I will take the questions towards the end of the session. So I'll talk about execute commands and everything. And we also have Rituja over here, who is also very good with EnSight, so I might ask her to chime in as well. So keep sending me your question and answers, and I'll take them towards the end. Okay, so I was talking about variables here at the bottom. And the variables are basically whatever you've imported from Fluent or whatever you have created in EnSight itself. So if I go ahead and expand these scalars, you will see that these were the variables that I selected from the list of quantities exported from Fluent. Okay. Now, all of them show up as gray because they're not activated yet. They are there in the system, but they haven't been loaded yet. So if I wanted to go ahead and activate something, say, for example, if I wanted to activate the pressure, I could go ahead and just do that. And you will see that immediately the units show up, the range shows up, which is the minimum and maximum in the domain. And then it also has some other columns that tell us whether it's at the element center or whether it is at a node. Now, these are all the scalar variables. You also have velocity vectors over here. All right. And then if you had any constants in your simulation, that show up under this list. Now, because this is a transient simulation, I do want to point out that you also have the analysis time over here. So if I were to go ahead and click it and then drag and drop it over here on the white space, it'll show you the analysis time for the last time step. So by default, the last time step is the one that gets loaded into EnSight if you're doing transient analysis. So it is showing you that the maximum time is 1.75 seconds, all right? So if you wanted to perhaps record an animation or look at post-processing results, having this helps. I'm going to go ahead and deselect this for the time being. And let us talk a little bit about computed variables. So you have all these variables that you imported from Fluent. What if you wanted to generate another variable inside EnSight? That is a derived variable from your fundamental variables, right? So you can do that as well. I'll show you a very simple example. So you go to the top over here and there's something called the calculator. So you click on that. And then you could go ahead and assign a name to your variable. So let me go ahead and say test variable. Okay. And say, for example, I wanted to look at the temperature in Kelvin. Right now it is in Celsius, as you can see over here, right? So I can just go ahead and add 273.15 to make this into Kelvin. Okay, now obviously this is simple multi-phase simulation. I didn't even have energy turned on, I think, in Fluent. So this doesn't have an actual temperature field. This is just a reference temperature, which is a constant. But if you did have energy turned on and if temperature was a variable, then it would automatically get converted to Kelvin with the help of this extra variable. Now, after you've assigned that variable name, you have to select the parts for which you are computing this variable. So I can go ahead and select the entire case by clicking on this case 1 heading, and that automatically selects everything. And I can just go ahead and say evaluate for selected parts. The moment I evaluate it for selected parts, you will see that this gets added to the list of variables over here. Since it was a constant, it got added under the constants list. Okay. All right. So let us go ahead and deselect this and let us talk about the post-processing itself. So if you look at the parts list, all the parts have different columns. You can hide a part by just unchecking that particular box over here. You could also go ahead and click V on your keyboard, V for van, and that will toggle between visible and invisible. All right, just for the sake of convenience. Now, there are multiple ways of generating contours on your simulation domain. So for example, this is the fluid domain. If I wanted to color it by pressure, I could do a couple of things, right? So one thing is I could just right click on this highlighted row. And when I right click on it, a number of options open up. This is a very frequently used step, because not only if you want to generate contours, but if you wanted to clip a particular zone, if you wanted to generate a plane, if you wanted to generate an isosurface, if you wanted to change the style, all that can be done easily with the help of this right click. So right now I'm just going to go ahead and choose color by, and it wants to ask me, okay, which variable do you want to color it by? So I'll go ahead and select the variable. And I said pressure, right? So we will go ahead and select pressure. And the moment I do that, you'll notice that this entire fluid zone shows me the pressure contour and the legend over here. Now we can go ahead and vary this contour scale as well. In fact, we can do a lot of things. But before I do that, I wanted to show you another way of easily coloring any particular part. So say, for example, now I want to color this by the volume fraction. So I can also go to this variables tab here at the bottom, and then let us choose volume fraction of air. And I can simply left click on it, hold down the left mouse button and drag and drop it on the part that I want to color it with. And you will automatically notice the legend changing. It varies between 0 and 1. Okay. Again, the results are for this particular current time step. So for example, if I wanted to look at the 10th time step, it would look like this. If I want to look at the 5th time step, it would look like this. Right? So fairly simple over here. And if I wanted to go ahead and change the range or the color scheme or do some fancy things with the images that I generate, again, there are multiple ways of doing that. I could simply click on the part and then go to the top over here. This particular panel changes depending on the part that you've selected. So for example, right now I've selected a fluid zone. So this sort of a panel shows up. If I click on this color wheel over here, you will notice that you have an option of choosing edit palette. And if you choose edit palette, it'll give you the range of the legend, right? And you can change that legend depending on the parts that you select. In this case, the minimum and maximum for the computational domain and the part is the same. So it'll still be between 0 and 1. But if you were to go ahead and choose the selected part, then it would automatically clip to that range. You can also do some like really cool advanced stuff with the coloring over here. Say, for example, you could use this spline to make sure that, the results are more proportion to the darker regions or the lighter regions. It's really crazy the amount of things that you can do. But for example, you could go ahead and choose whatever color scheme you wanted to. If you wanted to go ahead and choose a grayscale, you could go ahead and do that as well. And you will see that, this changes accordingly. So it was selected, which is why it was showing up as orange. But once you deselect it, you can see that the contour effects take place. And then you could also go ahead and choose some other options as well if you wanted to do that. So that is one way of changing the palette. You could also go ahead and change the opacity if you wanted to. So for example, you could make it less opaque, and all that can be done inside this color scheme color wheel over here at the top. But if you wanted to go ahead and change the annotations for any particular variable, say for example, I want to look at the static pressure over here. All right. And if I wanted to go ahead and change the legend for the static pressure, I could also go to annotations, double click on this guy. And then you have a couple of more options for changing the legend itself. Say, for example, if you wanted to change the format of the numbers, you could switch from exponential to floating point and then select the decimal points available, right? And then you could also go ahead and change the title of this legend. You could go ahead and change the font if you wanted to. So all that is easily available to you. And like in the previous case, you could also go ahead and edit the palette from this option over here. All right. So that is what I wanted to cover on the palette scheme. Now let us talk a little bit about animations, because it'll be simpler to explain this with a 2D example. We have a transient case. We want to see how the result is progressing over time, right? So remember I told you about the solution time widget here at the top. What does it do? If I go ahead and just play this, you will notice how the variables are changing with respect to time. And you will see that the time steps are changing accordingly. This is the simplest form of animation that you can generate in EnSight. If you wanted to go ahead and export this animation, you could simply go to File, Export, Animation, and then only the solution time animation is available for this EnSight case right now. You could check, play, and reset, which means it'll automatically reset once the once the animation is done. You could put a file name. Say my file name is solution time. And then I can hit OK. And it saves an AVI file in your user files directory. So this is going to be saved in your user file directory. So you'll see that this is under user files. All right. And this was simple, but obviously, we can do such simple things in Fluent itself. There's no need to, come to EnSight for that. So what else can we do with animations, right? So there are some other ways of generating animations called the flipbook animation and the keyframe animation. Flipbook animation is when you've done a lot of post-processing for your case, right? You've created a lot of clips, you've created a lot of contours, and now every time EnSight has to generate an animation, it has to repeat that entire set of post-processing steps for each and every time step data. Now that can become tedious, that can become very time-consuming and jarring. So to get around that problem, instead of using solution time animation, you can use something called the flipbook animation. We're not going to be looking at flipbook animation today because it's the more intermediate case. But if you wanted to, get around the time taken to output some of the results, then flipbook animation is the way to go. But what we will be looking at is the keyframe animation. Now, the keyframe animation is this icon over here at the top, right next to flipbook. And this is one of the most advanced forms of animations that you can get out of EnSight. Why? Because it gives you a lot of flexibility with, controlling speed of your simulation, controlling the keyframes of your simulation, where to start, where to end, how do you want it to vary. And this is not just restricted to the transient nature of the problem. Actually, let me show you so that you'll understand a little bit better. So for example, I generated an AVI file that goes really fast, right? I want to control the speed of the simulation. How do I go about do that? So let me go ahead and generate a keyframe animation over here. The moment you select this, along with the solution time widget, there's a keyframe widget that becomes visible here at the top. Okay. Now, if, for example, so let me go back to the start time. This is where it's starting from, right? So if, for example, I wanted to start it at the beginning and end it at the last time step, then this starting point will become my first keyframe, right? So I'll go ahead and check keyframing. And I will go ahead and check transient data settings because it has to use transient data. I'll go ahead and check this and I'll go ahead and do create. Okay, so it has created one keyframe, which is my starting point. Now I want to make sure that I'm ending it at my last time step. So I'll go ahead and put down 13. The moment I do 13, this contour changes because the pressure looks different at the 13th. I keep saying time step, but the 13th time we are exporting it out, right? So this is my endpoint. So I'll go ahead and create another keyframe. Okay. See, now if I go to the keyframe widget, you will notice that it is active. It is not gray anymore. The reason is because now it has at least 2 points to denote the start and end of my animation. All right. So if I want to go ahead and vary the speed of the animation, I can simply click on speed and actions. And it says, hey, how many subframes do I want from my first keyframe to my second keyframe? So right now the default is 12. Let me go ahead and increase it to 50. Okay. And now let me go ahead and play this. So do you see how the speed of my animation reduced? When I was doing it in solution time animation, I wasn't able to control the speed. But with this guy, with keyframe animation, I can go ahead and do this. All right. Now, the other thing is that you don't have to limit yourself to transient data, right? I told you that you can also navigate in your user window and use keyframe animations to record that sort of an action. So what I do is, let me go ahead and delete the earlier keyframe animation. So I'm going to delete it back to the 0th keyframe. A good way to check that it has been deleted is that this should again be gray. All right. So this is again gray. I don't have any keyframes anymore. Let me go back to my first timestamp. It doesn't matter. It depends on wherever you want to focus your attention, right? So this is my first time step over here. Let me again go ahead and create a keyframe. But this time I don't want it to be transient. I just want to do something else, which you'll see in just a minute, right? So I will go ahead and create a keyframe. This is my starting point. Okay. And then I will go ahead and zoom in to this particular region over here. Okay, I want to see this region in more detail. So I'll go ahead and generate my second keyframe. Okay, and then again for speed and actions, let me go ahead and make this 100. So I'm adding 100 subframes from step 1 to step 2. Now if I go ahead and play this animation, do you see how the animation is not telling me the transient data, but just focusing in on any one particular region? So if I wanted to go ahead and maneuver around my model, say you're working with a lot of components, this would be a good way to, zoom in, zoom out of locations, change quantities, and even couple this with the transient progression of results if you wanted to. And how do I export the keyframe animation? Same thing, go to File, go to Export, Animation. And instead of selecting solution time, go ahead and select keyframes and then do the same thing. And it'll again export a video out. All right. So that is what I wanted to cover on the animation part. Let me quickly show you the example for the conjugate heat transfer problem, right? So this was a transient case. So let us go ahead and look at a steady state case and a few more ways of post-processing these results. So I'll go ahead and close this guy. And we will go ahead and look at the results for the conjugate heat transfer problem. I think somebody had a question earlier about can results from mechanical be processed by EnSight? Yes, to the best of my knowledge, they can be, because I've seen an example of doing a coupled fluid solid interaction simulation in EnSight. In fact, that is what EnSight is good for, because usually when you are doing individual simulations in CFD and mechanical, you would be choosing any one platform for doing the post-processing. EnSight lets you do a lot of that together. So yeah, you could do that. And I think another question was, what is the execute command setting for? So a good thing about EnSight is that you can record all the steps that you are following in order to post-process your results, and then reload those same steps for another case, right? And you can do that in two ways. Somebody said, how do I save a file in EnSight? Well, you save a context in EnSight, right? So you have the same context or the same set of commands that you've applied to one file, applied to another file that you load at a later stage. And by the way, in my workbench project, whatever data I have loaded or whatever post-processing I have done, I leave it at that and I save my workbench project. And when I come back and reload my EnSight, I have all the solution data and post-processing available to me. So that is another way you can go back to doing what you were doing earlier. All right, so let me go ahead and show this case. I don't want to go to Fluent in order to save some time. All right, So I have two cases here actually, and let me show this over here. All right. So in this particular case, I have let me go ahead and this is all colored by temperature, by the way. So let me go ahead and show you the individual simulations. What I basically have are two inlets over here that are my intake fan boundary conditions. So there's a simple pressure jump condition applied at these boundaries over here. And then I have a grill outlet over here, which is exposed to the atmosphere. And this is at gauge pressure 0. And in here, if I go ahead and hide this guy, you will notice that I have two heat sinks. And the heat load is applied at the bottom over here on the circular surface as a heat flux. Okay. Now I wanted to show you guys how to kind of do the post-processing for a conjugate heat transfer problem where you do have the energy turned on and the temperature variable is visible. So you can see that, you know, I have everything colored by temperature. For example, an easy way to do this, instead of coloring by temperature, say I wanted to color by pressure, I could simply go ahead and drag and drop pressure from this list over here to the white space over here. And when I do that, everything automatically gets colored by pressure, the ones that are visible, okay? And if, for example, you wanted to individually color a part, then you could drag and drop that variable on that particular part. All right, so let me go back to temperature actually, so that this would be a little bit more visible over here. So these are the heat sinks. You can see how the heat is progressing through this heat sink, and you know, it gets cooler as it goes to the top. I said that this is a steady state case, but you still see the solution time at the top over here. And that is because I had another case imported into it, which had particles in it. And the reason why I have this case is because I wanted to show how to export particles from Fluent into EnSight. So I will cover that in a little bit, but that case is transient, which is why you see the solution time over here. All right. So you have this case over here. All right. What if you wanted to go ahead and create a clip through this fluid domain, right? So you could go ahead and choose the fluid domain, which in this case is, I would say, the enclosure. And then I can go ahead and select, right click on it and select clips. And if you wanted to go ahead and create a clip in the Y direction, you simply go ahead and do that. The moment you create a clip, you will see another part getting populated in this parts list. All right. Now, if the part is selected, and this is a derived part, meaning it has been created from another part, then while it is selected, if you scroll in the list, you'll see a P indicated against the parent part. This is very important when you're doing advanced level post-processing in EnSight, because depending on the properties of the parent part, your derived part changes. So for example, if this was not a 3D enclosure, but say a 2D surface, and I would have created a clip out of it, it wouldn't be a 2D plane, it would be a 1D line. So depending on where you're creating a clip plane from, a lot of the properties can change depending on the parent property. So for example, this was colored by temperature. You will notice that the clip plane is automatically colored by temperature over here. Okay. So for example, if I go ahead and hide this and only show you the clip plane over here, right? you can see the temperature on this, which is not very clear right now because the palette is not conducive to visualization. So let us go ahead and select a different palette. So let me go to files and I'll choose rainbow. Okay, so now this looks to be a little bit more familiar with what we usually use. All right, now this clip can later on be colored by pressure. It can be colored by velocity, whatever you want to choose, you can go ahead and choose that. Right, so now this changes to velocity magnitude. All right, now you have one clip plane over here. If I wanted to perhaps compare this case to another case that I've loaded, because that is one of the beauties of EnSight, right? You can do comparisons. And admittedly, this case and this case, you know, they're similar, they're not very different. But if I wanted to go ahead and choose this case too for comparison, I could go ahead and do that as well. So say, for example, I go ahead and I create another viewport, right? So say I go ahead and click new. This viewport is in addition to the main viewport, which is this guy over here, whatever we were using till now. All right. Now in this viewport, you will by default see the same component loaded as is loaded in your main viewport. This might be important if you're trying to isolate certain parts and do localized post-processing on them, or if you're trying to compare one case with another. Viewports help in splitting your graphics window to do side-by-side comparisons. If you wanted to go ahead and rearrange the viewport so that they occupy equal space, you could go to viewports layout and choose to vertical. And that would give you these two planes in these two viewports. All right. Now, what if I wanted to, so for example, what if I had a particular way of visualizing my results in one viewport and I wanted the same view to be copied to the second viewport? So I can right click on this white space over here. I could choose copy transform and I could come to this other viewport and again right click on the white space and do paste transform. So that way is whatever you've done in the first viewport automatically gets copied onto the second viewport. All right. If I wanted to go ahead and link these two viewports, I could do that as well, meaning that whatever transformation, whatever changes I make to my first viewport will automatically get copied over to the second one. So I could go ahead and right click on this again and choose link here. And I could do the same thing over here. Now, when I move one, the second also automatically moves. Okay. Now, this is a good way of, doing side-by-side comparisons. Like I said, whatever is going to be available in viewport, main viewport will be automatically available in viewport one. So for example, if this guy is also available here, right? And I wanted to go ahead and hide this from the second viewport, but keep this in the first viewport, I could go ahead and choose this. Okay. And then I could come here at the top and there is this button over here that shows per viewport visibility, right? So I could go ahead and click on that. And this part that is selected, if I wanted it to disappear from the second viewport, I would simply go ahead and select this guy. And that way all the other remaining parts are visible, but the part that I deselected will automatically disappear. Okay, so this is one way of using viewports in EnSight to do side-by-side comparisons, right? You could also go ahead and send a part to a new viewport. Meaning, for example, if I went ahead and chose case 2, okay? And I go to edit at the top over here. Since all the parts are selected and I want to send case 2 to a completely new viewport, I could go to part and I could go to assign to single new viewport. Okay. Now in this viewport, all my case 2 entities will be visible. Okay. And that is completely different from case 1. And I could do the same things that I did to viewport 1 and viewport 2 over here to my case 1 and case 2. Right? So for example, if I just wanted to keep these two guys over here. So now case main viewport has case 1 and then viewport 2 has case 2, or maybe it is the other way around. But if you had two cases that you wanted to compare, this was a good way to compare it. Now, one thing that I wanted to cover before I end the session is how to do a particle export, because you know, that is one thing that a lot of people, a lot of questions have come in the past from our customers. How do I, you know, export particle data? So let me go ahead and quickly show that on the Fluent end of Fluent side of things. So for example, I am doing a transient simulation in which we have some discrete phase particles, right? So how do I go about exporting the particle data, which is separate from continuous fluid data, and import it into EnSight? So let me go ahead and turn on Fluent. So this was the same case that I was just showing you guys. But the difference between that case and this case is this was solved in a transient way. When we are doing transient flow for both the continuous phase and for the particles, there is a lot of data that is generated and it takes some time to load into EnSight, which is why I went with a steady state case. But as far as the particles go, what I did, just for the sake of an example, is that I created some injections over here at the inlet. So here are the injections that I created by turning on discrete phase model. Excuse me. And these were massless particles, right? They weren't really interacting. They were not really affecting the flow. Just, you know, as an example, I'm sure when you do your discrete phase simulations, you might have different physics that you have to take into account. But for example, if I wanted to export this particle data that is changing with time, right? Because the particles are flowing in the domain, how would I do that? So I set up this injection like normal, okay? And then in the calculation activities, along with the export of the solution data, so like if I go ahead and show you the solution data, in this case, I did the same thing for the earlier tank flushing case. The only difference is that instead of selecting the CDAT format, I selected EnSight case gold, right? So this writes out a .ncase file, which you can later import into EnSight. But apart from the solution data, let us look at the particle data over here. So what you basically do is you select create and you select particle history data export. When you do that, this dialog box opens up and it'll ask you to select the injection, which is the source of your particles. So you go ahead and do that. You select EnSight, you assign it a name of your choice, and then you mention the frequency at which these particle related data will be collected. So right now I have assigned after every 10 time steps, okay? And then there is this particle EnSight file that gets created, okay? So this is a different EnSight file than this solution data export. And so you'll have to choose that from the directory, okay? And the other thing is, hey, which variables do you want to choose for the particle? So if you go ahead and click on this, you will notice that there are a number of different particle variables to choose from. So you can choose whichever particle variable is of interest to you and hit OK. And those variables will be exported out. The only thing is that you'll have to do it once for solution data and once for particle data. All right. So you can go ahead and cancel this guy. And if I now open EnSight over here, I'll show you what I did for importing the particles. So this is case 2. Let me show you for case 3 actually. So let me try to import this again. So you go to File, then you click on Open. And it says, hey, do you want to keep the currently loaded data or do you want to replace it? Right? So if you want to compare two cases or load additional data, select Keep Currently Loaded Data. Since we already have 2 cases, this third case that we will read in already gets the name case 3. Okay. And then we can go ahead and choose link operations for all cases, meaning if your case is the same, the geometry doesn't change, the mesh doesn't change, the variables don't change, at least the ones that you import from Fluent, then you can go ahead and link all the operations for all cases. But in this case, I'm not going to do that because one was transient and one was steady, so it can confuse EnSight. So I'm going to go ahead and do OK. And it'll open up the directory where you have all this simulation result, right? So if you scroll in this particular directory, you will notice that there is a separate encase file for particles. There is the original particle file, and then there is the final particle file. Original meaning beginning of the simulation, end of the simulation. So you can go ahead and choose the new encase file, and it automatically gets appended with new. So you would know which one is the newer one. And then you import that in. Once you import that in, you will see that because it was transient in nature, this widget shows up. And let me go ahead and hide the other cases so that it is clear. And let me only show you case 3. Okay. So in this particular case, if I go ahead and expand this guy, let me hide everything and only choose the particles and the inlet and outlet. Sorry, the 2 inlets. So you can see these particles that have been emitted from the inlet because it was a surface injection that was starting at the inlets. If you feel like the particles are too small, you can also go ahead and choose something over here at the top, which basically allows you to scale the particles a little bit more. So I could make them crosses, or I could make them spheres. Okay. And if I go ahead and run this simulation, you can see, I mean, it did not have a lot of time steps saved, so it doesn't vary much, but you can see how the particles are moving with time that were emitted from the inlets. Now, keep in mind, this is just the particle data. It doesn't have any continuous flow variables. If you wanted to also look at the air domain or the continuous flow domain, then you would have to load the solution data. So remember, in Fluent, we had exported both the solution data and the particle data. So both have to be loaded into EnSight in order to view everything together. All right. So this is all that I wanted to cover from a content point of view. Hopefully, for those of you who are unfamiliar with EnSight, or those of you who had some knowledge of EnSight, but perhaps did not know a few tips and tricks, benefited from this session. Please feel free to let us know, your comments and feedback. We always take that into account to try and make these AVAs better. And before I go, I'll see if you guys have any questions. Sure thing. Thank you guys for your time. We have our next AVA session in October. It's going to be Intro to Composites in Ansys Mechanical. and it's going to be hosted by our simulation lead, Pedro Chu. So stay tuned for that. It's going to be a good one. And as always, please feel free to leave your comments and feedback. Thank you so much. I don't see any more questions, so I'll go ahead and end the session. You guys have a good one.